All right, so looking at 4-8, analyze equivalent expressions on page 245, we're going to start with the solve and discuss it. So this says, how many toothpicks make a triangle? 2 triangles. Write an expression that represents the number of toothpicks needed to make X triangles that appear side by side in a single row. And then explain your reasoning. So let's just start off with the first triangle here. Now, in order to make this first triangle, we need a total of 3 toothpicks. So I'm going to kind of make this into a little table. For each triangle, I need how many toothpicks? So for one triangle, I needed a total of 3 toothpicks. Look what happens to make the next triangle, though. The next triangle, I need just an additional 2 toothpicks. The toothpick from the first side is still being used, or from the first triangle is still being used, meaning we only need 2 more. So in order for 2 triangles we made, I need 5 toothpicks. Looking at the next one, to make another triangle, I only need 2 additional ones because it uses the toothpick from the last one. So for 3 triangles, I need 7 toothpicks, so on and so forth. So write an expression that represents the number of toothpicks to make X triangles that appear side by side in a single row, and explain your reasoning. I want you guys to try that out. So, because there's going to be different answers for different things. And the reason I say that is because the next question is, can there be more than one expression? I'm letting you guys know now, yes, there can be. That represents the total number. You need to think, how many toothpicks, or what expression or what equation can you create to make the chart true? So even just looking at the next triangle, I know we're just going to add 2 more toothpicks to it. So if I were to have 4 triangles, that would be 9 total toothpicks. But say if I wanted to know how many 10 triangles would be, how many toothpicks would that be, as well as what equation can you use to help you find that? So this is very much a you try problem. I want to see what each student comes up with, because once again, there are multiple answers. So because there's multiple answers, I want you guys to try this, solve and discuss it out. Go ahead and pause the video and see what you guys come up with. So that's really all what today is going to be. We're going to be writing these different equivalent expressions in order to show that, hey, there's more than one way to write out different scenarios. So looking at example number 1, it says a new box of pasta claims that it contains 25% more than the usual box. What expression shows the amount of pasta in the new box? So the very first thing that they do is they really love a good visual, which I don't blame them. They start by drawing a bar diagram to represent this problem situation. So this P represents this original amount of pasta. The new box represents 25% more. So this is the more, this is the original, meaning this here is the total in new box. That's going to be the total, P plus 0.25P. And if you're wondering where that 0.25 came from, remember 25% is just 0.25. So that's going to be the total in the new box. From there, the next step, they just combine like terms. P plus 0.25, this is the same thing as 1p. So 1 plus 0.25p is going to give you 1.25p. And then from here, this is just an extra little note. It does say that 25% more than 100 is 125%, which is just 1.25 written as a percentage. Keep in mind with percentages, you just move that decimal over 2 times. And to make a percentage a decimal, you do the same thing in reverse. You take it and move it forward. So we're not going to be dealing all with percentage problems, but it is a good thing to remember. So we're going to try it together since it deals with another percentage. It says Joe is buying gift cards that are on sale for 15% off. He uses C minus 0.5C to determine the sales price of gift cards. What is the equivalent expression that Joe could use to determine the sales price of the gift card? So notice here that C is the amount of the gift card, the original. Of gift card. So looking at the blue portion, if it's C minus 0.15, this is the same thing as 1 minus 0.15, and they just have that C attached along with it. So 1 minus 0.15 is 0.85C. Now, what portion did they take off? What is coming off of this? Well, that's going to be the 0.15, that 15% off, 0.15C. So what equivalent expression could Joe use to determine the sales price of the gift card? If I'm just looking for the sales price, we can use 0.85C. C minus this will give me my final result. That's 0.85. C, because C times that gift card will give us the final amount. Now, how do you know if the expression is describing a percent increase or percent decrease? Well, we use our signs. So a percent increase is going to be addition. A percent decrease is going to be subtraction. It's all about the terminology. And as long as you know your terminology, as long as you know your words, you should be good. Now, another thing to also add is this 0.85. Notice what's happening. We have that subtracting, so it brings us to something that is a decimal. 0.85 is less than 1. Therefore, that could also represent that decrease. Now, say if it was an increase, say if we wanted to add it, like the problem up above, this would be an increase as well because we added it and it's greater than 1. 1.25 is bigger than 1. So that's something to add to, is that if it's less than 1, then you're going to be dealing with a decrease. If it's greater than 1, it's going to be an increase. We almost got ahead of ourselves. I almost got to the example problems. So with example number 2, it's looking at this picture, super similar to what we've done before in our boxes. It says some middle school students will use a 1-foot tile to create a frame around a large square mural painting with the sides of S feet. 3 students wrote an expression to determine the number of tiles needed. Are these expressions equivalent, and explain? So one thing to note is just to solve. So notice here, 4s plus 1. Well, if we were to use that distributive property, this would come out to be 4s plus 4. So that would be our first area. Looking at the next one is an s plus s plus s plus 4. s plus s plus s plus s is going to be 4s. And then plus 4 just comes down as well because of the fact that it is a constant. So far, those do equal. Checking the very last one, we have this 2s plus 2 times s plus 2. We would have to distribute, which would give me a 2s plus 2s plus 4. We would have to combine like terms, 2s plus 2s, which would give us a 4s plus 4, which also equals. So we are able to state down here the three expressions are equivalent because they each represent the number of tiles needed for the frame around the painting. So they all equal one another. These would be equivalent expressions. This is another way to write equivalent expressions when they all equal one another. Now, number 3, interpreting these expressions. Now, a table with a rectangular top has an extended tabled leaf as shown. Multiply to write an equivalent expression for the total area of the extended table. What does each term of the equivalent expression tell you about the table? So this goes very much back to what we've learned even in our IXL practice, where they wanted you to find the area first. They did 3.5 times 6.5, which gave us this 22.75. And they also did 3.5 times x, which represents that. Now notice what I've done. I've color-coded because each of these represents the area. Area of a rectangle in general, this will always be length times width, or length times height. So with that, we have to look at the first rectangle. The first rectangle has a length of 3.5 and a width of 6.5. Therefore, the area would be that. Now, the table or the extender, the leaf, has a width of 3.5 and a length of x. Therefore, we would multiply those together to get this area. So after that, we really do just add them together because they're being put together, which would give us our final result. Now, the reason we cannot combine these is because they are not like terms. We cannot combine unlike terms. So we leave the answer as is. We cannot combine these, so we simply leave it as 22.75 plus 3.5x. Now this try it below is kind of working backwards. It says the total area of a rectangular stage that has been widened by x feet is represented by 1900 plus 76x. Use the distributive property to factor the expression. And what does each factor in the equivalent expression tell you about the stage? So it wants us to factor this. Rather than doing the distributive property, we need to factor. We have 1900 plus 76x. Now, you will need a calculator. If you can do this by yourself, if you do not need a calculator, then you do not need to be in 7th grade math. We need to put you in algebra or something because that is great. But what you would do, let's just start off with 76. Let's start off with the biggest number that can go into 76, which is itself. This can be split into 76 times 1. Now, your main question you need to ask yourself when factoring is, can 76 go into 1900? I've done this math, and it does. 1900 divided by 76 will give us a 25. So that means what we do, because you know I like to erase it, I have a 76 and a 76. 76 gets pulled out. Now, what got left over after I pulled out that 76? Well, what got pulled out from that first one is going to be, or what got left is 25. So that's what you write, 25. Keep your plus sign. Your plus sign stays the same. And then you multiply 1 times x, which is just an x. Now, what does this represent? Well, this is going to represent your 76. That 76 needs to be multiplied by both of the rectangles. Therefore, it is the length of both the rectangles. Whereas your width, notice what we have here. We already have an x. We have an x that's being left out, but we have to plus this 25 as well. So we can say, what does each factor of the equivalent expression tell you about the stage? That 76 is the length of the extension, and I'm going to do it in big capital letters, and original, whereas the x represents the width of extension, and 25 is the, I'll do it down here, width of the original. Notice we still have, origin. Notice here that we still got to add those together. We still got to add them together, but they are two separate parts, and that's why we have to add them. The only thing that's going to be the exact same is this length here, because it's the length of both the extension and the original stage. But that's the main thing that we're going to be doing with these examples, is that we are going to be simplifying. Now, I'm going to do the do you know hows, and then I'm going to do I'll do the odd problems for the examples. So looking at the very top, number 4, rewrite the expression 12x plus 8 to find an equivalent expression. Show 3 possible expressions. What do the rewritten expressions tell you about the relationship of the quantities? So there's a lot to do in this example. It's not just one little step. Now, I would take it one piece at a time. We learned back in the previous units the commutative property. Which allowed me to switch the terms if I have addition. So using that commutative property, I'm just going to switch my two terms. That is probably the easiest way to go about this, is to switch my terms using the commutative property. Now, that's just one way, though. Both of the other ways, I'm going to use factoring. So if I factor, I'm going to show my work off to the side for my red. 12x plus 8. I'm actually going to factor 2 different ways. I know 2 goes into both of these numbers. More specifically, 2 times 6 will give me 12, and 2 times 4 will give me an 8. So because of that, I'm going to pull out a 2. I'm going to factor, pull out a 2. That left my 6x plus 4. Now I can actually factor one more time. Say rather than a 2, I know 4 can go into 12, 4 times 3. Now same ordeal here. I've already written that 4 times 2 is the only way I can break down that 8. But now I can pull out a 4 rather than that 2. When I pull out a 4, that left back in 3x. And my 2 got left behind when I pull out the 4. Now, if you were to check this, all of this would come out to equal this expression. So what is the relationship? They all equal one another. They are all equivalent. They are all going to be equivalent to one another. And that's simply by using that commutative property as well as factoring. Now looking at number 5, a rope is used to make a fence in the shape of an equilateral triangle around a newly planted tree. The length of the rope is represented by the expression 9x plus 15. Rewrite the expression to represent the 3 side lengths of a rope fence. So you need to know a couple of these words here. So we have an equilateral triangle. So an equilateral triangle is going to be a triangle with all sides equal. Therefore, the length of the rope, that's going to be perimeter. The perimeter of the triangle is going to equal 9x plus 15. Now, how many sides are there in a triangle? Well, there's 3 sides in a triangle, and we need to know the length of one side. All of this will equal 9x plus 15. There's 3 sides of a triangle. Each will have the same length. That length will equal 9x plus 15. All right, so from here, there are a couple different ways to do this. I'm going to probably show you the best way to answer both of the questions at the same time, and that's by factoring. Now, we want to factor 9x plus 15. The main thing that we need to do, though, is that we need to focus on this 3. So I know I want to pull out a 3 from both of the numbers. Why? Because the triangle has 3 equal sides. An equilateral triangle is going to have 3 equal sides. So 3 times what's going to give me 9? Well, 3 times 3. And 3 times 5 gives me 15. That gives me the 3 that I was looking for. That gives me the 3 for the 3 sides of a triangle. Leaving what left over? Well, it leaves a 3x plus, because my plus sign does not go away, a 5. A 3x plus 5. Now that's rewriting the expression. What is the length of just one side? Well, this represents the length of the 3 sides. So one side would simply be 3x plus 5. If 3 times 3x plus 5 represents the 3 sides, wanting one side is simply the expression on the inside. Which brings us to number 6. The expression x minus 0.35x represents 35% off the cost of an item x. How is this equivalent to multiplying x by 0.5? We're going to solve this by simply solving x minus 0.35x. When you subtract 1 minus 0.35, that gives you 0.65. Therefore, when you subtract 1x minus 0.35x, that's going to be the same as 0.65x. 100% minus 35% will give you 65% of the total cost. I'll write it under of the total cost. So that's how it's the same. All you have to do is subtract them. 1 minus 0.35, and that's going to give you your result. Now, scrolling on down, I am going to do the odds just because 7 came first. So looking at this, we're going to start off with the reasoning problem. It says Eric is planning an event at a hotel. Let G stand for the number of Eric's guests. The 2 expressions represent the difference between the cost of the rooms. Expression 1 and expression 2. What can you tell about expression 2 and expression 1? Well, at this current moment, we do got a lot going on. We have the hotel function rooms as well with the prices, and then we have two different equations or really expressions going on. So something that I just noticed off the bat is that we have a subtraction problem going on here. So expression number 1, and I'm just going to say 1 and put a little colon here, represents the difference. Now, what is it representing the difference of? If we look over to the chart, we have 326 plus 37G. We have the booking fee plus the price per guest at the Ocean. So that's going to be the total if we add them together. 326 plus 37 times G, which is $37 per guest. Keep in mind that per is multiplication. Now subtracting the harbor fee. So this is the total for harbor, 287 plus, this says 23 per guest, because per guest is going to be multiplication as well. So this represents the difference between the hotel rooms. And we just showed that here, where yellow represents this ocean and the harbor represented that green, and it is the difference. Now, expression number 2 is a lot different than what we're used to. So let's just try out a little experiment. Let's just see what's happening here. And I'm going to show my work off to the side. Say if I were to go ahead and just subtract. I have a 326 plus 37G. I got that from just the Ocean. That's the Ocean price. And let's just subtract. I do need to put it in parentheses. That harbor, so 287 plus 23G. Keep in mind whenever you do the subtraction, you do have to do the opposite. We learned in 4-7 that we do when we subtract. Expressions. Turn the terms inside the parentheses. I'm actually going to put something else here. I'm going to say add and. Okay, so this total thing here says when we subtract expressions, add and turn the terms inside the parentheses to the opposites. Now, the reason I added this little bit here, add and, is because we have to turn this minus sign into addition. It also goes to its opposite. And then after that, we go opposite, opposite. So now I'm just going to combine some like terms. I have a 236 minus a 287. I have a 326 minus 287. And then I have, let's do that one in blue. I have a 37G minus 23G, a positive 37G minus 23G. So whenever I combine those like terms, something nifty happens. And if you don't have a calculator, this is when you might want one, unless you can do it in your head. 326 minus 287 is going to come out to be a 39. And then a 37 minus 23 comes out to be a 14 or 14G. Look what happened. Look what value that gave me. 39 plus 14G. So expression number 2 represents solving, or I'm not even going to say solving because we didn't solve it. We simplified expression number 1. And we just did that. We showed all of our work over here off to the side. We simply simplified the expression to give us something a little bit nicer, a little bit easier to work with. Now, let's move on to number 9. We now have Karina buys boxes of crackers that each have the same cost C. She represents the cost of 3 boxes of cheese crackers, 2 boxes of poppy seed crackers, and 2 boxes of plain crackers using the expression 3C plus 2C plus 2C. What equivalent expression can represent the cost? So with this, we just need to combine our like terms. They all cost the same. She bought 3 plus 2 plus 2 boxes, which comes out to be a total of 7C, or 7 boxes total. And they all represent the same cost. So cost is just C. All right, looking at number 11, a farmer recently sold a large plot of land. The sale decreased his total acreage by 8%. Let V represent the new acreage, or V represent the original acreage, the original. It said find 2 equivalent expressions that will give the new acreage. So this just means we need the old minus the decrease. This will equal the new. So we've also already been told that we're letting V represent the original, meaning V we consider being the old or the original amount, minus the percent decrease. Now with this, 8% is going to equal 0.08. So if we wanted to subtract, we need 0.08% of the original or the old amount. Now, what's kind of nifty is that this gives us our first answer. This is one of the 2 ways that we can write the new value or the new amount of land that he has. The other way is to simply solve. You can do, this is the same thing as a 1V. So 1 minus 0.08 is going to come out to give you your new one of 0.92. And we have to have that V because that V represents the original acreage. Now, use the expressions to describe 2 ways to find new acreage. I'm going to split this in half since I do have 2 different numbers here to describe 2 ways to find the new acreage. We've kind of already done this. We're just going to use this little statement here to write something new. V is the original amount, and you would subtract the decrease, the sale decrease. To find new amount. And then I'm even going to put a big fat equal sign because this is equal to what the new acreage is. This represents that subtraction, which is 92% of the original amount. Because keep in mind as well that amount, that 0.92 is the exact same as 92%. And we learned that a couple of units ago. All right, number 13. Use the structure of the area of a rectangular playground has been extended on one side. The total area of the playground is that. Can this be rewritten? Write the expression to give the possible set of dimensions. So once again, we're just going to kind of break this down. The very first thing is that the area of a rectangular playground has been extended by one side. I'm going to draw this playground, and we're just going to use the markers. We're not going to pull out the shape. Oh, no, I'll pull out the shapes. Make things a little bit easier. We'll make this a little smaller. So this is our playground. Blue is going to represent our playground. Blue is the original shape of the playground, and we are extending it. Now, that's a big extension. We're not going to extend it that much. We're going to extend it by around this much. We want it the exact same. There we go. And we're going to turn to a different color. We're going to edit it. It's going to be, we're going to say it's yellow. So blue is the old, and the yellow is the new. Now keep in mind, we still need to know area of a rectangle. That's going to represent your length times width. Now it says the total area, this whole area is going to be 352 plus 22x. Now rewriting the dimensions, we just need to factor. So with this factoring, this factor will allow me to find the length and the height of everything that I need for this playground. So we need to factor 352 plus 22x. The very first thing I'm going to start off is probably going to be the easiest one. Let's see if 22 can go into 352. And the reason I did 22 is because it is the largest factor of 22. So 352 divided by 22, that works out. 22 divided by 352. I need 16. It's going to be a 16. So that tells me that 22 gets pulled out, leaving me with what on the inside of the parentheses? Well, a 16 got left behind. That plus sign needs to come along with me, and a 1x got left behind. Now, what does each of these numbers represent? Well, that's where you now need to go back to the rectangle. So that 22 is going to be the height or the length of both the old and the new. So it needs to go all the way over here, representing both of those lengths. Whereas now you have the old side and you have the new side. Now the old side, I'm going to say is going to be the 16. We knew that it was 16. It's going to stay 16. And we added a new length of x. We're going to say we don't know what that x is, but we just know we added onto that playground. So that's where the 22 times 16 plus x came into play when we're looking at a thing like this. And once again, if we were to multiply, this would be 22 times 16, which is that 352, plus 22 times x. So it also works out. All right, looking at number 15, this seems to be the last one, and it is the longest one. I'm going to go until I hear that bell ring. Once I hear that bell ring, that means y'all are going to be rushing in from PE, and we'll need to get this uploaded so y'all can start it. So I'm going to go until that bell rings. It says, a customer at a clothing store is buying a pair of pants and a shirt. The customer can choose between a sale that offers a discount on pants or a coupon for a discount on the entire purchase. Let N represent the original price of the pants and S represent the price of the shirt. Write two expressions that represents 15% off sale on all pants options. So we're buying both, is buying a pair of pants and a shirt. So I know that he's buying pants and I know that he's buying a shirt. And really the pants is represented by N and that shirt is represented by S. With this, write two expressions that represent 15 on pants. We still have to add those together to give us our total, but we have 15% off pants. So 1N minus 0.15, that's your 15% off, plus one pair of shirt because you cannot use the discount on the shirt. So with this, if we were to combine our like terms, 1 minus 0.15N is going to be 0.85N. And then we have to bring along that S with us. Now after that, you have write an expression that represents 10% off the entire purchase. And that's where I'm stopping. That was the bell. You have the rest to do. If you have any questions, please let me know, and I'd be more than happy to help you out.